Welcome back, students. This is a second lesson now on energy. If you are starting this here and you haven't done the lesson on types of energy, and also I recommend if you can do the eScience 3000 lesson on the forms of energy before doing this as well, it'd be helpful. Just want to make sure that eScience is honestly going to go in a little bit more depth here, so I want to be able to clear up more of those conceptions through this video. This one's going to be a lot shorter than the first one, or the first lesson. I'm sorry that it took so long to get through all that content. It's just really important to review and make sure we're all on the same page, especially in terms of like, hey, how are we going to do class? So once again, for this lesson, you are going to be watching this video. As you go along, I'd like you to take guided notes. You can find that in the Google and the classroom assignment, but it'll be right here. This one's it's not as filled out for you, but there's honestly, it should be pretty straightforward. And I'll try and stop here and there as well, just to make sure you know where you're supposed to be going. Okay, so back in here, we just talked last lesson about the types of energy. And if you remember, there are two. There's the type of energy, or there's the types of energy that are stored up and ready to be used to change matter, which is what energy is, and we call that potential energy. And there's also the types of energy that are currently actively changing matter in some way, either moving it or changing its condition, and that's called kinetic energy. So kinetic energy, simply moving energy. Potential energy is stored up energy, stuff that's ready to be used. So this lesson we're going to actually dig into the forms of those energies. So it's kind of like a folder within a folder. You have two big folders for energy: stored, moving. But inside of those two different folders, there's lots of different types of energy, but we're going to call them forms of energy today. Sometimes on the internet you're going to see they flip-flop it. They say there's two forms of energy. You have kinetic and potential. Really, that word doesn't make a difference, and I've seen it either way all over the place. So for now, we're going to talk about forms of energy today, the kinetic forms of energy and the potential forms of energy. Very fascinating stuff, and you're going to recognize them all over the place. Let's start with one misconception. A lot of people think that renewable energy is a form or type of energy, and it isn't. Renewable energy is more of it's partly technology. It's just ways of getting energy that comes that will renew itself. You'll get more of it in our lifetime. So keep that in mind maybe, but this is kind of tangential to this. It's not necessarily important to understand that. So let's do now real quick. I'll simply take 3 minutes. I'm actually not going to have the timer on the whole time, but try and describe the energy that you see in this picture. We talked about potential and kinetic. Is it moving? Is it stored up? A mixture of both? What do you think? Take a second, think about it. Okay, you can unpause your video now. If you said both, you're correct. There's a lot of potential energy and there's a lot of kinetic energy. But if we want to go beyond just describing it as stored up energy and moving energy, and actually dig into what it is, what is changing about matter, or what's stored up in the matter, this is where we're going to dig in today. So if you know anything about lightning it's a mixture of electrical energy. It's a mixture of that and radiant energy, which is lightning, right? We call light energy radiant energy. It radiates outwards. You have a tremendous amount of thermal energy as well. And there's a bunch of other stuff too. Sound that comes from that. It doesn't directly produce it, but it goes along with the sound of that. So there's lots of energy. The potential energy is the stored up electrical potential between up and down, basically between the earth and the atmosphere of things rubbing together through friction. It's kind of a funky one, but you know, we're going to cover the main 8 right now today. So if you have your notes up and open, our objective is to describe energy as the property of objects that's associated with heat, light, electricity, magnetism, often the same thing, mechanical motion, and sound in order to understand the thermodynamic behavior of our bodies and real-world objects. Whew. Thermodynamics just means basically energy and motion. It doesn't necessarily even just mean thermal energy, even though it sounds like that. We're just basically saying you'll be able to describe the energy of objects, what kinds of energy there are, and how our bodies also take part in moving energy this way and that way. So the essential questions: what are the different forms of energy and how are they related to the types? Forms of energy. All energy falls into two categories, like we said: potential, stored, and the kinetic, which is moving. But just to be clear here, this stored energy can be any kind of stored energy. It's either from position, which gravity sometimes can create positional potential energy, or say a rubber band, which is actually, it's stored up in the bonds of the molecules, these what's called long elastomeric polymers, these long chains of molecules that can stretch but want to go back to where they were before. So based on the condition of either being stretched or just in a relaxed state, you're going to have potential for motion, which could be motion of waves, electrons, which are tiny parts of atoms that, if you remember, those little tiny negatively charged parts of atoms that move around, molecules, and substances. And on the grander scale, we're just going to talk about it in terms of the motion of those things, like heat, which we measure with a thermometer. So the potential forms of energy, you have chemical. Part of chemical is elastic potential energy. This is like rubber bands, like I said. You might think, oh, it's its own potential form of energy, but what's actually going on inside of a lot of elastics, things that come back to where they are before, even like springs on a car's shocks are elastic, meaning that they will come back to where they were before. That's actually all to do with the molecules themselves inside that object. Say it's a spring leaf on a car's shocks. It's the molecules themselves that hold the energy in place and then are able to go back together. Nuclear energy, gravitational energy. I'm actually not going to read through all these just yet in depth. And then there's only 3 types of potential energy that we're going to be talking about today. And then kinetic energy, which is radiant energy, also known as light energy, electrical energy, motion, which is just like a catch-all. If we don't know how to describe it, but we know it's moving and it's causing matter to change in some way because of its motion, we're going to call it motion energy. Sound and thermal energy. Let's dig into each one of these. And if you're in your notes right now, you should be filling out the top part of it. This box right here should look exactly the same as this box. So just make sure you understand that these are 8 of the most common forms of energy we're going to be talking about a lot. And I think even with this, you should be able to describe most of what's going on out there. And it's important to understand that they do get separated into these 2 categories. You're not going to have radiant energy that is potential sometimes and kinetic. It's always moving. And we're going to talk about why that is right now. It's a lot to remember, right? And I never ask you to memorize these things. You're not going to get a test on this, but you should know. And how to best to remember? Maybe you can use a mnemonic device. Cam Newton got really excited making sticky tacos is my favorite. If you take, in other words, the first letter of each of these words, they should represent the actual form of energy. So Cam Newton got really excited making sticky tacos. In other words, Cam, chemical, Newton, nuclear, got gravitational, you see the rest. So the nice part about this line here is it also helps to distinguish these 3 up here are the potential forms of energy. And all of these 5 down here are kinetic, actually moving. You notice motion sometimes is just called mechanical, even though mechanical energy is really potential and kinetic put together. People out there just go anyhow. They say whatever. So we're not going to go off what they say. We're just going to go off of what I say. And when you learn it from whatever professor, eventually just listen. It's just a language. Everybody has their own ways of saying it. So chemical energy is the first form of potential energy. This is energy that's stored up in the bonds of atoms and molecules. Water has chemical energy in it. Sugar has potential chemical energy in it. These are bonds of these long chains of atoms that your body's able to rip apart, and in the process of ripping it apart, it turns it into electrical energy or thermal energy or motion. And that's what your body's constantly using. It's the reason that you eat food and drink water, because you need the chemical energy that's held up in those molecules. And sometimes one thing is going to allow another molecule to break apart. Like if you don't drink water, you're not going to be able to break apart the molecules in the food to actually get the energy out of them. So drink your water. Maybe go take a stop now and go drink. An example of anything that's chemical is stuff that burns, stuff that dissolves stuff, all that ability to change matter in some way that's held up in the chemical bonds themselves, like what makes a molecule, is considered chemical energy. Okay, moving along here. I remind you, you can stop and go back anytime you want. Okay, Newton. This is nuclear energy. So energy stored in the nucleus of an atom, we took a look at atoms before multiple times this year. This is just one representation or model of it. The energy that's stored up in these actual protons and neutrons, keeping them together, is what we call the nuclear energy. So that nuclear energy can get released in a couple different ways, either from not neutrons, but the nucleus of an atom coming together or ripping apart. That kind of stuff happens in nuclear power plants here on Earth, but it happens much more powerfully, meaning a lot more of that energy getting ripped out per second when it fuses together in the heart of a star, like we saw in our recent eScience. Gravitational potential energy. This is what we said before. This is a positional energy. So depending on how far up something is, the more potential energy it's going to have. It's basically the more mass it has, the higher up it is, the more energy it's going to end up getting if it gets released. It's stored up energy. This is the easiest one, I think, to see that it's stored up, because the further up you go, the more you're storing it, the heavier it is. You actually have more potential for it to turn into kinetic energy. Okay, so I want you to grab something around the house, or maybe multiple things, and just make some observations and inferences right now. I'm also not going to keep the timer for this. You don't have to write this down anywhere, but just try and make some observations and then infer which one has more potential energy. Do yourself a little science experiment, and I'll see you in a second. Okay, we're back. I hope that you were able to make the connection of how high it is and how much mass it has in terms of how much potential energy it has. And it's not something you see until you actually let go of it. Okay, going on to our kinetic forms of energy. We have radiant energy, which is electromagnetic energy. This isn't electricity, this is actually photons. When we hear light radiating out in a ray, it means it's going in one direction. That could come from the sun, it can come from your house light. The only difference between those things might be different properties of the light, which we'll talk about later this year, and how much of it, which is the intensity. The sun's obviously pretty intense compared to, say, your cell phone's flashlight. So go take a look around your house real quick. See which ones have radiant energy. Do some light bulbs in your house have more radiant energy than others? How do they measure that? Okay, we're back. Once again, I hope this doesn't feel too awkward. It feels a little bit awkward for me, but hopefully you've gone out to see those things and make some observations and inferences. Okay, electrical energy is the next form of form of kinetic energy, because there's actually electrons flowing. These electrons flowing is what creates electricity, or what we call electrical energy. If you plug in your object to an outlet and you get a lot of electrons at a time, something that's able to draw many out, you're getting more electrical energy out. There's plenty of different ways to get electrical energy. Take a rubber balloon and a latex balloon and rub it against your head, you're going to actually pull electrons off of it onto the balloon, which would be static. They're stuck on the balloon. Other times you can actually, like, go zap somebody, right? When you see that actual arc of electricity, sometimes it'll come off as bright, but that's just basically all the electrical energy changing the air around it and making it glow. Go check out some electrical things in your house. Most things will have a little recorder on them saying, oh yeah, it has this much energy at this point coming in, or this many watts on a power surge strip. Those all are measuring how much electrical energy